Hello students, welcome in chapter 10, Vector Algebra. Today continue students, our example number 4. Find the value of x, y and z if given two vectors a and b are equal. Yes, when they are two vectors equal, yes, it's a magnitude and direction are same, then both vectors are equal. Here we apply both a and b are equal vectors. It means we will write down a is equal to b. And what is your a? X to z. Same b to y. Here nothing, then it is 1. Now compare each sides. X is equal to 2, y is equal to 2 and z is equal to 1. And here students, our example 4 very easily we done here. Now continue students, example number 5. Example 5 also asking related here equal vectors. If a and b given, vector a is that I plus 2j and b vector is 2i plus j, then possible checking magnitude a is equal to magnitude b, question mark. Also check a and b are equal vector. So when they are equal, if your directions and magnitude are same, first I decide magnitude. So we have to a magnitude here, a 1 2 0 and b vector is simple, we going that 2 1 0. Actually here ij k not given, so k rate I 0. Now I will cover to magnitude a. It is 1 2 0 and magnitude you know under root squares, 1 square 1, 2 square 4, it's the root 5. Same here magnitude b, which have to 2 1 0 under root of 4 1 and 0 root 5. Yes, my first target is achieved, magnitude of both are same. Yes, that's the first steps. But check here, they are also asking they are equal vectors, so no, because directions are different. But a and b are not same because both directions are not same. That's why we can say a and b are not equal. Yes. So last I going to now example number 6. Similarly, very easy topic, students. Example 6. Given vector, find the unit vector in these directions. So a vector given 2a, 2i plus 3j plus k. Find unit vector in the direction, in the same direction. So there are two types of unit vector, either in same direction, either in different directions. Here asking in same directions. Yes, so a I just cover 2 3 1. You go to first magnitude 2 3 1 and magnitude formula simple, you know that, under root 4 square x1 square x2 square and x3 square, and you can apply whole square. So here 4 9 and 1 10 root 14. That's your magnitude, but I want to unit vector, so required unit vector in the same direction of a. Yes, so a cap, a by magnitude a, Listen here students, if you given same direction, then you write down positive. But if you given opposite direction, then here mention minus a. And a value already known you have to 2, 3, 1. And magnitude is a root 14. So my answer is 1 by root 14. I just covered to 14 outside and here 2i side 3j plus 1k, and that's your simple answer for example number 6. Now students continue, same asking but having some magnitude given. Example 7. Find the vector in the same direction of given vector having magnitude 7 units. Yes. 7th, find a vector in same direction of A already given that I minus 2j having magnitude 7 units. Yes, it means I going to simple first unit vector, and now after that 7 units I just multiply on it and they get the multiplication of 7 unit vector. So students, first of all you clear a vector 1 minus 2 0, its magnitude cover 1 minus 2 0 under root 140, it's a root 5. Now I just cover unit vector. Yes, unit vector a cap is a by magnitude a, and what's the a? 1 minus 2 0 by root 5. Now students wait, question read, find a vector in same directions having magnitude 7 units. So required vector having 7 magnitude in the same direction. That's why I take positive, 7 times a cap. If the opposite direction given, then minus 7 times a cap. So 7 times it is a 1 by root 5. 1 minus 2 0. It means 1 by root 5, 7 minus 14 0. So finally I write down 1 by root 5, 7i minus 14j plus 0k, and that's target. It's your magnitude 7 with your unit vector in same directions. Now continue example 8. Very easy. Question is there, given vector a and b, find the unit vector in the sum of the given two. Yes, find unit vector in the sum of a twice I 2j minus 5k, and secondly twice I j plus 3k in same direction. Yes, in the same direction a and b, asking that in the both summations 2i 2j minus 5k and 2i j and 3k. Students, first of all I both making sum because I want to in the sum of the both unit vector. So a plus b, so a I have 2 minus 5 2 1 3, and total taking 2 plus 2 2 plus 1 and minus 5 plus 3. So 4 3 minus 2. Here I just consider it is a r vector, but I want to both sum after that in the unit vector same directions. So magnitude of r cover 4 3 minus 2 is under root 16 9 and 2 square 4, 25 plus 4 29. Yes, so required unit vector in the same direction. Yes, it's very easy. It is r cap. So your target r vector by magnitude of r vector. And what is the now r and r vector? R I have 4, 3, minus 2. And that is the root 29. So your answer is 1 by root 29. There is 4i 3j minus 2k. And here students, a simple answer to sum of the both vector in the same direction of unit vector is done. Now I continue students. Example number 9. Yes, asking that direction ratio and direction cosine. The given vectors, find out direction ratios and direction cosines. Vector A given I plus j minus 2k. Then find direction cosine and direction ratio. It's very easy. Direction cosine and direction ratio asking that. So students, first of all I define my vector in the form of unit vector. So what's your A? 1, 1, minus 2. Very easy. Magnitude A? 1, 1, minus 2. So 1 plus 4. It is root 6. So what is the unit vector? In the same direction? Yes, it's simple way, A cap, which is A by magnitude of A. Unit vector defined, then after easily you going to direction cosine, direction ratios. So A, our vector is a 1, 1, minus 2 by root 6. It means 1 by root 6, 1 by root 6, minus 2 by root 6. These are our direction cosines. So that is your direction cosine. It means students, first value is a cos alpha, second value cos beta, and third value cos gamma. And also direction ratios are, first of all, 1 by root 6, 1 by root 6 and minus 2 by root 6. And here students, easily your example 9 also students, you are happily done. Now continue. Example number 10. Chapter is very easy, just only you properly understood our points. Now example 10 going. P and Q, 2 points given and asking that directions for the P to Q words. So very easy. P is given 2, 3, 0. It is points. And Q is a minus 1, minus 2, minus 4. Then find direction. Find direction. Simple. P towards Q. It means PQ asking. Yes. So very easy. P is the initial point. Q is the last point, terminal points. So that's I just plot one of the P here. 2, 3, 0. Secondly Q, minus 1, minus 2, minus 4. And you can define easily direction of PQ. It's very easy. Position vector of Q minus position vector of P. Yes. Position vector of Q minus position vector of P. Position vector of Q is a Q small and here's P small. Now what is your Q? Minus 1, minus 2, minus 4. P I have 2, 3, 0. And simple you calculate. Minus 1, minus 2, comma, minus 2, minus 3, comma, minus 4, minus 0. It is minus 3, minus 5, n minus 4. That is your p towards q directions, and that's my target. Yes, only asking that pq. Now continue. Example number 11. 3 minus 5 minus 4. In backside answer this way written, minus 3i. I also write down, don't worry, 5j and minus 4k. That's my PQ directions. Now continue. Example number 11. Very easy, students. And 11 have now going to division ratios related P and Q, given that and asking that internal and exterior divisions of the question number example in the 11th. Yes, students. Now continue, students. Example 11. Consider 2 points P and Q with the position vector given OP and OQ directions, and I want to find the position vector of the R which divides P and Q. 2:1, one time in internal division, one time in external divisions. So first of all, I explain you division for internally. Yes, internally, our first of all you taking internally divisions. So consider that's your one of the 2 points P and Q. Here your direction for O, OP and OQ. And that's your division for R. I want to R in the ratio. Here OP directions already known, 3a minus 2b, and OQ directions is also known, a plus b, and internal division also given ratio 2:1. So our position vector of R, very easy, 2:1. Just like mx2 mx1. Here consider m, ratio n formula. So m with position vector of q plus n with position vector of p upon m plus n. That is your division theory, lambda theory. Now there are the 2:1, backside 2 plus 1, and now value put it. What's the value? qa is a plus b. And here that 3a minus 2b, and now calculate. So they have to answer 2a 2b plus 3a and 2b minus upon simple 3. It means you will getting 3 and 2 like term added, 5a plus this and this cancel, 0 by 3. And here students, you simple getting position vectors of R. Now after that I go to now external division, students. So students, now I start our next point, external divisions, and that related we just start for again define for R divide PQ in externally. So my second case, division for now externally. Externally means ratio I just taking minus 2:1. Drawing is same. That's your O to P directions, O to Q directions, and here the ratio R, but externally, so minus 2:1. And what's the P? P is your known 3a minus 2b, and Q is also known, a plus b. Now students, I going to same as position vector of R. In the way of now, same property apply, just 2:1 place I write down minus 2:1. So here students, minus 2:1 by minus 2:1. Here a plus b same, and that is 3a minus 2b same. So minus 2a minus 2b same, 3a minus 2b upon minus 1. So indirectly total you have to a minus 4b by minus 1. So can we write down 4b minus a by 1? That's your position vectors of R, and simply with that ending now. Now continue. Example students 12. Given three vertices, prove that it is a vertex of right angle triangle. Yes, given vertices A, B and C already given, and prove that it is vertices of right angle triangle. So example number 12, continue. For the triangle ABC, A I have twice I minus J plus K. B I have I minus 3J minus 5K. And C 3I minus 4J minus 4K. Yes, there are the three given. One more time check. 2I minus J plus K, I minus 3J minus 5K, and 3I minus 4J minus 4K. Yes, prove that vertices of right angle triangle. To prove vertices of right angle triangle. It means to define one angle is 90 degree by utilization Pythagoras theorem. I just make first distance by our directions wise. AB distance, AB directions. B, what is the A? Just I write down here 2 minus 1 1 1 minus 3 minus 5 3 minus 4 minus 4, and that you create students distance for the directions. 2 minus 1 1 1 minus 3 minus 5 and 3 minus 4 minus 4. Here B minus A. B I have 1 minus 3 minus 5, A 2 minus 1 1, and here you can decide it your distance. So 1 minus 2 minus 1. Now minus 3 plus 1 minus 2, and last minus 5 minus 1 minus 6. So you have to 1 4 36. It is root 41. First distance. Now BC distance I will go. BC means BC directions. So here C minus B. You can create very easily your solutions. But apply BC. Either CB both correct. But in magnitude correct. BC. So C minus B. C I have 3 minus 4 minus 4, and B 1 minus 3 minus 5, and calculate. So 3 minus 1 here 2. Now minus 4 plus 3 minus 1, and minus 4 plus 5 1. It get 4 1 1 root 6. Now third distance AC. AC also I go to now AC directions C minus A, and apply this similarly. Here your answer students in the way of direction CB means C minus A. What's your C? 3 minus 4 minus 4, and A 2 minus 1 1. Now calculate students. 3 minus 2 1, minus 4 plus 5 minus 3, and minus 4 minus 1 minus 5. It get 1 9 and 25. So 30, 25 and 10 35. Yes students, check. 35 square plus 6 square, it is 35 plus 6, it get 41. Means Pythagoras theorem valid. So can we write down BC square plus AC square? BC square is a 6, 35, 41. It's surely AB square. Means your right angle triangle, here easily we can derive that in the direction of 3 lines. That here A, what the direction for A to be hypo? Means C is a right angle. Yes, A, B are a hypotenuse. So we can say angle ACB is a pi by 2. Therefore, triangle ABC is right angle triangle. That's why you can say last. So given vertices A, B, C are the vertex of right angle triangle. Yes students, here up to 12 now done. Now students, I continue our exercise 10.2. Yes, slowly I going now. our exercise. Very interesting and very easy exercise, students. 10.2. Now question number first. Given vectors A, B and C, define that its only magnitude. Yes, only magnitude asking, students. So find magnitude of vectors are A, I, J, K. Second vectors 2I minus 7J minus 3K. And students, third C vector, which is 1 by root 3I 1 by root 3J and minus 1 by root 3K. Students, here only you find out magnitude. Magnitude formula known, under root x1 square, x2 square, x3 square. Yes, here A is what? 1, 1, 1. So its magnitude is under root 1 square, 1 square. It's the root 3. Now also, what's your B vector? 2 minus 7 minus 3. 2 minus 7 minus 3. So what's your magnitude B? It's very easy. Under root 4, 7 square 49 and 3 square? Yes, 9. Total you getting 49 plus 9 and 4, 13. So 9, 10, 11, 12, 1 carry 62. Now also last C vector. What's your C? 1 by root 3. 1 by root 3 and minus 1 by root 3. And that's the magnitude. Students, here I think this magnitude is 1 coming. Yes, it is a unit vector. I mean value for 1 magnitude. It is under root 1 by 3. 1 by 3. It is 3 by 3. Means only and only you can take 1 value. Now continue, students. We are going ahead. Our exercise second one. Second also very easy and interesting questions. Yes, and after that given, we are going to now question number 2. 2 and 3 students both are our same questions, so I explain both 2 and 3 combined. So students, first I explain here for second one, after that third, after that fourth. Very easy and short question. Write 2 different vectors having same magnitude. Students, magnitudes are same but different. So here just any answer, yes. But suppose we can write down A vector and B vector. Just like I written 1, 2, 3. Magnitude you know. It is under root 1, 4, 9, root 14. I want to different vectors but magnitude are same. So same I write, just only 1 minus. Either 2 minus, either 3 minus. It is different vector. Either you can change their positions, here 2, here 1, here minus. That different that. Yes, magnitude same, check that. It is under root 4, 1, 9. It's a root 14. It means A magnitude, B magnitude are same. But they are different. A never equal to B. And that's your students first example done. Here you any number write, any. Yes, in the way of different. Now second 2 different vector having same directions. So in same direction I just explain you about that. This octane form, I just take one vector on the x-axis, one of the x-axis. It is same directions. Possible? No. This way. Here one vector is A vector taking 1, 0, 0. Second I take B vector 2, 0, 0. Check. Both are different but having same direction. Either in this side x dash also possible. So here students, suppose your A vector is a 1, 0, 0 and B vector is a 2, 0, 0. See, both are the same directions and different. Yes, A and B are in the same direction and both are different, A never equal to B. They are not same. Here students, you done now your third sum. Now fourth, x and y, find out both vectors are equal. Very easy. A equals to B. What's your A? 2, 3, 0. B, I have x, y 0. Now equality. Your equality, x cover to 2, y cover is a 3. And simple get students, your answer is 2 and 3. Now continue question number 5. Very easy questions. Now in the fifth one, yes, initial points given and terminal points given, and define that only that scalar parts and vector parts. Students, here initial points, just consider A 2, 1 and last point. Terminal point B just like a -5, 7. Then find its a scalar and vector part. Yes. Then find scalar and vector part. It's very simple. You just define first A towards B directions. A, I have 2, 1, 0. Here -5, 7 and 0. And first set direction towards A to B. And that's your position vector of B. Minus A. -5, 7, 0. Minus 2, 1, 0. Now answer. -5, -2. -7. 7 minus 0. Sorry, 7 minus 1. 6. And 0 minus 0. 0. So can I write down -7i plus 6j plus 0k direction AB. So my first part, scalar part. Yes, scalar part. Only you can write down -7, 6 and 0. And students, vector part. Yes, vector part is a -7i, comma 6j and comma 0k. It's very easy and simple. Yes, now continue our question number. After that fifth, now sixth one. Sixth also very easy students. Given vectors and find out that only A, B and C given and find out all summations. Yes. Question 6. Find sum of given A vectors, B and C. So A, I have I minus 2j plus k. Second, B minus 2i plus 4j plus 5k. Minus 2i, 4j and 5k. And C vector students, I minus 6j minus 7k, and find out all summations. So very easy. You can just define what's your A plus B plus C. A, I have 1 minus 2 1 1 minus 2 1 plus B, I have minus 2 4 and 5, and C 1 minus 6 minus 7. Students, you can attach first data 1 minus 2 plus 1 comma minus 2 4 minus 6 minus 2 4 minus 6, and last 1 plus 5 minus 7, 1 plus 5 minus 7, and calculate answer. 2 minus 2 0, 4 minus 8 minus 4, and 6 minus 7 minus 1. It get 0i minus 4j minus 1k, and that's students simple answer. Now seventh one, find the unit vectors of the given vector. Yes, find unit vector in same direction. Find unit vector in the same directions of A given, you have to A vector I plus j plus 2k. Very easy. Unit vector already you known. Simple going. Your A parts 1 1 2 1 1 2. Now magnitude of A. It is 1 1 2 and calculate 1 plus 1 plus 2 square is how much? 4. So it is root 6. So required unit vector in the same directions. Yes students, in same direction must be you sure. It's your A cap, A by magnitude A. Your A is known 1 1 2 by magnitude A root 6. So finally students, I will done here in easy way 1 by root 6. It is 1i, 1j and 2k. 1i, 1j and 2k. Yes students, here up to 7 questions students, this is done, and here this part also students I stop there. Further explanations for this exercise I going in next part. Bye bye.